Excellent.
Can you hear me?
You sound great.
All right, perfect.
Floor is yours, sir.
I guess we'll get started. So today I'm going to talk about a couple of different um, network investigative techniques that I have the privilege to investigate and try and understand. I'll also talk about a couple of the legal issues and then discuss a proposed framework for how we can move forward with this and do testing in a way that's a little bit more open than what we've had in the past. So to start off with, we have the fact that law enforcement does need to do investigations, and they do a variety of different types of investigations. For quite some time, we've had telephones, and so for telephones, we have the ability to do wiretapping, and so that's to be able to eavesdrop on a telephone call that someone is making. Additionally, with websites, we have the ability to track who is connecting to a particular website, and then you can get, as it says, a search warrant based on where the person is who is visiting a website. So let's suppose you go to a terrorist website and that website is open to anybody, and then you can go in and figure out what IP address that person is coming from and get a search warrant to search their premises. Additionally, we have peer-to-peer file sharing. So a lot of people will share content using, networks like Napster back in the day, or some of the newer networks that allow you to share files. And again, you can get IP addresses out of that and figure out where they're coming from, and then get a search warrant again based on the locality of where the person is. So criminals have gone and decided that it's better to not get caught, and so they have invested in looking at different anonymization techniques. There are a couple different main ones. So we have I2P, which is the Invisible Internet Project, but that one is a little bit complicated to set up. Whereas with Tor, which stands for the Onion Router, Tor is basically you can download a program that runs Tor, and you can connect to the internet using Tor. And so what this does is the client or the person who's wanting to visit a website, their IP address is hidden. So you still know where the server is. And so if the server is hosting illegal content, then you can go and arrest the person who's running the server, but you have no idea where the clients are located. And so to combat that, Tor has created another method of accessing um, resources on the Tor network, and this is called Tor Hidden Services. So basically, with Tor Hidden Services, you don't know where the server is and you don't know where the client is, but they're allowed to connect to each other as long as the client knows the Tor URL of where they want to go. And so this provides a distinct problem for law enforcement in that they cannot figure out where the server is and they can't figure out where the people who are connecting to that server are located. And so, in order to combat this, they have had to resort to using new techniques in order to de anonymize the people who are connecting to these networks. So, the first case that I worked on was USA versus Cottom. So, the FBI had located a server in Omaha, Nebraska that was hosting illegal content. And after they had figured out who owned the server, they decided that they wanted to figure out who the people who were accessing that server were. So they wanted to figure out the clients of that server. And so what they did is they invested in the fact that they wanted to de-anonymize these people, and they developed, I believe it was 4 different ways of exploiting the client's browsers. So SWF is a Flash file, so Adobe's Flash. DNS is the method in which you can resolve host names into IP addresses. Java is a language that people program in. For example, at the University of Nebraska at Kearney, we teach people how to program in Java. And then JavaScript is code that, again, runs in the browser. And so they had access to this server, and so then they deployed these exploit methods in order to de-anonymize the users of that network. So when I was called in, I came in and I viewed what was on the server so that I could figure out exactly how this worked in order to test the ability of the NIT to function. And so my job was to verify that it did what it said it did and figure out if there were any methods where we could have error, or it reported an incorrect IP address, or why it would have not figured out an IP address. So we can see here in the top, I guess I don't think you can see maybe you can see, I don't know if can you guys see that where my cursor is? Maybe not. There, okay. I think I got it to work. All right, so we can see here in this generate cookie, it's generating different cookies based on the different types of methods. So we got one for JavaScript, we got one for SWF, and we got one for Java. And so what this did is it took the session ID and it passed that into this generate cookie function. So I'll put my there. Right, so it took the session ID and then, which is right here, it took the method, right? So either SWF, Java, or WS, and it put that basically into along with a key, which this is a secret key. So it basically took the method and the session ID, and it put them into a string that was delimited by, we have a @ character here, we have an @ character here, and then we had a $sign. And so the method and the session ID are these secret pieces of information. This is all generated on the server that's running the code. And so then what the server would do is it would generate, we got here some lines to generate these structures, and the comments that you see here are the comments put in by the FBI programmers. So I can see that it's generating a random IV and encrypt the JSON structure. And so it would take the data and it would pass it into this encrypt function with a particular key, and it would encrypt it using the CBC method and given a particular initialization vector. And so now that information is encrypted. So if somebody looks at it, they can't figure out what it is. And if we look up here, the API gallery key is a shared secret key that is assigned on the server that nobody has access to. So this is all running in PHP, and so you cannot see what that is. And so at the end of this generate cookie function, it just does a split on this. So it breaks it up into 40 character hexadecimal numbers, and it returns that as a number. And so every session is going to have a different number. And it takes that information, and for example, in the SWF, it sets it as this variable called ID. So now we have a secret that is relating our session to a connection that's going to get made back to the server. So the reason that I was brought in on this case was because the SWF, the source code for this file, was lost. And so I had specialized in reverse engineering at Dakota State University, and so they brought me in as an expert, as somebody who understood what the ramifications and how to reverse engineer source code were. And so this is the code that was generated from the reverse engineering tool that we use, which is called JPEX. And we can see here that there's a function called load gallery. So load gallery is the main function that gets called when this SWF gets loaded. And so a couple of things that it does, it actually, down here, it accesses that parameter that was in the previous slide. So this is that encrypted cookie that relates a session of somebody who's logged onto the site to a connection that's going to get made back. We actually have two different methods that are used in this. So the first one is going to be this DNS. And so what it does is it generates a DNS name that starts with the IP address 96.126.124.96, and then it puts that cookie inside of here, and then the website or the domain is cpimagegallery.com. And so what it does is it tries to make a connection on that. And if the user hadn't set it up so that DNS queries went over Tor, then this connection would be made over the regular internet, and you would be able to see the source IP address that is connecting back to the FBI's website. The second, so that's the lookup of the DNS name, and then we have the second one, which is the onConnect method. So this is going to make a TCP connection on port 9001 that contains the information, including the capability of the OS, the architecture of the OS, and then again, that parameters.id is that encrypted cookie. And so if it makes this connection on port 9001, it bypasses the proxy that is set up for the Tor. And so it avoids all of Tor and makes a direct connection back to the FBI. And so then they will get a true IP address, and they will take that IP address and they can go get a search warrant for the residence, the person who is located at that IP address. So here we can see an example of that DNS name again, and we can see this long, again, it's broken up into 40, at most 40 characters. So the encrypted cookie is from the A8 right here up until we get to the CP image gallery. So all of that is that encrypted cookie, which can be decrypted by the people at the FBI. But if you don't know what that secret key is, then that you don't have any way to decrypt that. Now on the server end, they did do data logging, and they did it via a couple of different ways. A couple of issues that they had to handle was the fact that Flash would ask for a policy file request, and so they generated a policy file request that Flash would use when it was connecting back. But you can see in here that we have this method called decrypt cookie, and the decrypt cookie will go ahead and figure out what the board that they were visiting, which in our previous example was 1, the method, which would be SWF, and then the session ID that was related to this connection. So they get information about who is connecting, and then they go ahead and log all of that information. And when we tested it, we found out that it would, again, show the information like this is running Linux, it was running x86, and then we have the cookie that is being stored. So that is all logged to a normal log file. Additionally, they also would store the data in a MySQL database, and this was so that they could easily query that database. The log file is just text that just keeps getting appended to the text file that's doing all of the logging, but it's a lot easier to run a SQL query than it is to go through that log and try and reparse it. So they did do database logging as well as the logging to a log file. And then we can also see that it also does print off some debugging information with the log when it is doing that direct connection. I think I discussed that. All right, so here we can see that again with the DNS, right? So this is a DNS server. We can see that it also does the extract cookie and then decrypting it. So the cookie is stored in the domain name, and so it has to split up the domain name based on information in there as, for example, where the dots were for the IP address that we saw in the previous slide. And again, it did also do logging to both the database and to the log file. And then the decryption is actually fairly simple, but it does try to, it verifies that the cookie is stored in hex, and it will decode that hexadecimal cookie, and then it will take and it'll decode the hexadecimal value, and then the key here, right, is passed in and used to decrypt the data that is stored inside of the cookie. And so It uses the key, so it's the same key on both the client and the server, so it's symmetric encryption as opposed to using asymmetric encryption. And this was to make sure that nobody, you can't change any of the values inside of that cookie and get a valid cookie. Now, what it contains inside of it is the session ID, and the session IDs were logged on the server, and so you could relate a user on the server and what they were actually doing on the server to what IP address they had. And so then you had a correlation between activity and what their IP address was. And so this information was used when the government was building up their case for, you know, what they were accused of and what evidence was related to that. Now, for the most part, all of this information that we were given, so most all of these pages, except for the flash file, the government believed was what we call law enforcement privilege. So it was information that the law enforcement had the ability to keep secret, but they chose in this case, they did not think that it was related to the case. They thought that it was akin to if you were to break into a house or the law enforcement were to enter a house that had a lock on it. And if you had a person with a lockpick set, you unlock the door, that they felt was not relevant to the case of what did they find inside of your house. Now, we make the argument that digital systems is a little bit different in that the exploits that were used by this could be used by anybody, and therefore we would need to be able to verify the entire system to make sure that it wasn't doing anything that it shouldn't be doing, or that somebody could abuse the system and make it so that they could pretend that it was somebody else that was visiting the site or spoof somebody. And so these are going to be issues that we'll talk about here in a little bit. So that was the first case. Now, the second case is called the Playpen case. And once again, we had a website that was hosting illegal content. And if you want to look it up, this is the case number that is related to. And in these cases, basically what we have been given is this code down here called the NIT code. So the NIT code is a piece of code that runs on the client's computer that just reports back information as to what their username was, what operating system they were running, and then again a unique identifier. So if we look in this drawing that I have created to conceptualize it, we can see that the server that was Playpen had some code to generate a unique identifier and then take that unique identifier and integrate it into the NIT so that it was part of the NIT code that was deployed. And then I am assuming that they would log this information. So they have said that they logged it, but they have not shown us any of the code that's related to, other than how they generated the unique identifier, they haven't showed any of the data as to how that unique identifier was managed on their server so that we know that somebody didn't insert additional entries to frame somebody or do something like that, or that somebody had access to it and they removed somebody's entry. So we don't have information as to how that worked. We were given the NIT, but it was also, there was an exploit that was used. Now, if you look at the previous case, the exploit was basically Flash was not smart enough to use the proxy server that was set up for it. So somebody was running Flash on their browser, and it would bypass the proxy settings in there. And so the Tor project has fixed that problem. And so this has left law enforcement with the need to run an actual exploit. And this is an exploit that basically gives complete control to the computer, to the agents that are running this operation. And so what they've said, and I tend to believe them, but I, again, don't have the code, is that the only thing that they ran was the NIT. And so they've testified that, yes, the only thing that we ran was the NIT. But again, we haven't been able to verify that because they have not given us the exploit and they have only given us the NIT. And so then what the NIT would do is it would make a connection via the normal internet with some data, which included a unique identifier, and then the government had a server which that was connecting to, and the government would log all of that information that was related to that connection. So it would log the unique identifier, it would log what IP address they were connecting from, and then they actually would capture even a packet capture or PCAP of that and save that information to a hard disk so that they could use it later when again they were building up their case. So some of the issues that we have here. So the first one is Rule 41. So I believe it was last year they were discussing how Rule 41 would be modified in the future. But during these cases, Rule 41 said that a magistrate judge with the authority in the district, and if there wasn't one available, a judge of a state court in the district, has authority to issue a warrant to search for and seize a person or property located within the district. So these are rules that the magistrate judges in districts all over the United States use in order to determine who is it that you need to go to get a federal warrant in order to search somebody's premises. Now, the NIT was deployed in, I believe it was the Western District of Virginia, so, you know, where the NSA and FBI have offices. And so they went and got a warrant from the judge that was in that district. And so the issue that we have is that the people who were de-anonymized by this NIT, the main property of it is that we don't know where they are. And so if you deploy a network investigative technique that is going to basically search somebody's computer and return back an IP address, you don't know where they are. And so they didn't go around to every district in the United States, and they didn't get a warrant from every single judge. They got a warrant from one judge, and then they assumed that that warrant would be legitimate even though they were searching people's computers all over the United States. And so there have been a few of the cases that have been thrown out because Rule 41 was violated. Not very many. Most of them said it was done in good faith. They were, you know, the FBI was doing the best that they could, and so they couldn't be held in a court of law that that's not a valid way to do it. Now, what happened was Rule 41 was changed such that now if a magistrate judge issues a warrant, then that can be used to search anybody anywhere in the United States. Now, this NIT was, the number of people accessing this website was approximately 100,000 during the 13 days that the FBI controlled the Playpen server. And so of that 100,000, I believe the number to date is about 200 of those people are within the U.S. who have been arrested because of that. And part of that is because there are a lot of people outside of the United States that were actually accessing this server. And so those people are subject to the laws that are in their jurisdictions or their countries. And so the United States has worked with some of them in order to export that data of here's an IP address of a person who is on this website, and this is the evidence that we have, and they will work out those issues with them. But we've also seen that there's been another recent story about Australia has actually ran the site for months, and some people are akinning that to them running a website with illegal content versus them just watching who is connecting to that. So this is one of the issues that we have. A second one is related to testing. So in the world of developing programs, what you want to do is you want to be able to test all of the entire system and make sure that the code does what it says it does. I mean, none of us would appreciate it if we got arrested or pulled over for speeding and nobody could go and test the radar gun to make sure that the radar gun was accurate. So that's something that we have been arguing in court is, yes, we can test the NIT code, and I tested it and I verified that it does exactly what it says it does. But that is that is not the exploit. So the exploit is the thing that actually gives control of your computer to somebody else who caused you to visit a website. And so the special agent did do some testing on his computer to verify that it, in his words, didn't make any changes to his security settings. But one of the interesting things is an exploit, once you serve it to somebody's computer, if they had been watching information on the network, they have access to that exact exploit. And they can change the payload so that instead of running the NIT code, it could run anything. And so the FBI has sort of kept this secret for probably a number of reasons. Probably the most positive one is that they are saying that they use it in cases of terrorism or in cases of drug dealers, if they want to de-anonymize them, or if they want to de-anonymize some high profile target. So they're claiming that they need it in order to keep national security, and I have no way of saying that they aren't or that they are, but this is an issue that keeps going forward. They're going to have to keep using techniques like this. And so these are some of the issues where we'd like to have the ability to test this, even if as researchers I cannot publish anything on this as far as outside of a court. I should at least be able to test it and verify that it doesn't do bad things, right? There, what cases does it report errors? What is the known error rate? And those are some of the legal questions that we've had based on this. And so in that vein of thought, what we would like is we would like a framework that allows us to be able to test the entire system. And so, the things that we need if you are in software testing or if you're in software development, you think about what are all the things that you need in order to develop a system. So if you're running a website, right, you need to configure some sort of OS. You have software that's on it. So if it's running Apache, you want to install Apache. Well, then you got to configure Apache, right, to make sure that it works. And maybe you install a module that's not part of Apache, or you're running PHP, and so you need to install an additional PHP library that will make your website work. So we also need that because every one of these pieces of data is actually going to have some code that is going to get run. And that introduces the ability of us to have possible error. And so that's what we need to test. Network configuration, right? So if we're running behind a firewall, that would be important. Or if you have a hardware firewall that only allows certain connections in, right, that would be a good security thing. And so figuring out how exactly all of these systems are configured is important in order to have an environment to test the framework. And then having the source code is very key. If you looked back at my slide where I talked about the reverse engineering of the code, there were no comments in that. And comments, if somebody is writing code and they put a comment in, it makes it a lot easier and a lot less time consuming in order to figure out. And so we need that source code so that we can figure out what are the things that we need, what are the things that we need to test, what are the edge cases that could affect this. We also need the binary code because that is the actual binary that gets run. And so there have been errors with compilers, or compilers will optimize out parts of source code. And so making sure that we have the binary code so we can verify, oh, this is exactly what was run on that computer. And the FBI has given us the actual NIT code that has run in these cases. So they do recognize that they do need to give us the binary code that ran on those computers. And then the testing procedures to, if there were edge cases that the FBI had known about, then they could use those, we could use those test procedures in order to verify that, again, it did what it said it did, and what are the issues that they were concerned about so that I can go and very specifically look at those edge cases and figure out which ones do I need to look at, which ones maybe they were off by one on an array bounds, and so I need to go maybe check that. And then the last one is what network captures did they actually do with this? So, that's again something that they have been willing to provide, is they have provided the binary code and they have provided network captures. And so that would also verify that yes, when I ran this binary code on a machine that was similar to my client's machine, then I can verify, yes, this network capture is consistent with that. And so this is the framework that I've been working on, so that maybe in the future, when we have very complicated investigative techniques, we can actually verify that they do work as they say they are supposed to. And then here are some of the references, some of the stories that are related to it, some of the declarations, some of the cases that are have been talked about, and I've worked on quite a number of these cases. So I think at this time, if there's any questions, I might be done a tad bit early.
Oh, thanks, Dr. Miller.
So I do have any.
Yeah, so does anybody have any questions? Please feel free. Um, Go ahead and type it in into our question box. We have Kevin with a question coming.
The question is, how does subject matter experts help in determining the validity of the exploit slash case? Well, so some of the things that we have to verify in these cases is that, so very specifically, the search warrant will exfiltrate, the search warrant will specify some information that can be collected. So, for example, in the Playpen cases, the search warrant very specifically said that the FBI was allowed to collect a MAC address, a computer name, the user's name on the computer, and the IP address. And so, part of what my job was to verify that, okay, if I do run this exploit, this is exactly what they did collect. So they collected what they said they collected. Um, and other things that we need to verify is that, so what happens when there's an error, or suppose that the user has antivirus installed. So does that antivirus, because of the way it's doing hooking at the low level, does that antivirus actually make it so that it gives a wrong result, or that it causes the user's computer to crash? And so those are some of the things that I've been asked to look at. And so I've gone through, again, in the NIT code, I've very specifically gone through, and I actually debugged it, and I went line by line and verified this is exactly what it captures. And then I ran a packet capture on my own network to make sure, yes, this is the exact information that I got from that. And so that's what my job is to do that research. And then, as an expert witness, my job is to explain that to people who are judges and lawyers who do not have the technical background to understand exactly what we're talking about, right? Their expertise is in the law. So my job is to explain that to them in a way that makes sense to them. And so using analogies is always useful in that area. Does that answer your question, Kevin? And I think, Denise, there is a recording that will be made of this. Any other questions? All right, well, if anybody has any other questions, that'd be great. Otherwise, I thank you all for listening to me ramble about the things that
Certainly not a ramble. Thank you very much for that presentation. I know it's insightful to me. Thank you very much, everybody, for showing up. If you give me one moment, I will post a link to where our recordings will be available, particularly today's recording and past ones. And Dr. Miller will provide us a PDF version of the slides for you guys. Give me 1 second.
Yep.
Okay, so if you look there in your chat window, I posted a link, and the recording will be available almost immediately, and give us about 24 to 72 hours for a download of it. But with that said, that